So in the last video we talked about, I talked about it. Well, you didn't say anything. Maybe you said something. I don't know. We talked about absolute convergence, and now we're going to talk about conditional convergence. We said, so let's just reiterate. I'll just say it in words. If the absolute value of a series converges, then the regular series is said to converge absolutely. And we know now, hopefully, with that argument, we can say that if a series converges absolutely, then we know that the regular series just regularly converges. Hopefully that makes sense. So now we want to see, and we also noted that if the absolute value of the series diverged, we can't say anything about the original series. And that's where conditional convergence comes in, and the alternating series test. Test with a T, not tests. Before we actually look at the alternating series test, I think what we're going to do is talk about conditional convergence. So we already know that absolute convergence is if the absolute value of the sequence, and you take the sum of that, if that converges, then the regular series, you can say, converges absolutely. And that all that means is this converges. And then it implies that the original series converges. Okay, so conditional convergence means that this diverges, but the original series converges. So, if this is just by definition for conditional convergence, if the absolute value of the series diverges and the regular series converges, we say that that series is conditionally convergent, or you can say converges conditionally. The problem is, at this very moment, we don't have a way to tell whether the original series converges or diverges if this diverges. So what do? We move on. We just forget about it. We just leave. No, we have a test actually. We learn the test and then we use it. So what is the alternating series test? That's what we're going to go over right now. So here are the conditions. I haven't finished writing the whole thing, but here are the conditions for the alternating series test. Suppose we have a specific type of series that looks like this, where it's definitely alternating because of that key part right there. So you have some negative and it alternates between 1 and -1. And you can manipulate your series so that it fits this form. But suppose we have this type of series where a sub n, there's three conditions, where a sub n is positive. So if we remove this part, we only have a positive sequence that we're summing up. A sub n is decreasing. So each term is smaller than the previous term. And if you took the limit of this, it approaches 0. So it's decreasing, and it doesn't, I mean, we already know it's positive, but it's going towards 0, not going towards some other number. So if you satisfy these conditions, so suppose we have this where those are true, then the series converges by the alternating series test. That's it. You just have to make sure you have those three conditions. And they're really easy to check. For decreasing, you don't actually have to take the derivative and ensure that that's negative. You can, but for these problems, they're going to be sequences, and they're going to be like not super complicated, like with the ones that we had for the integral test. So you'll be able to see them that they're decreasing, because if the bottom is just growing larger and larger, you know it's decreasing. So, and then a sub n being positive, that's easy to check. Limit, that's easy to check. So this will be a fairly quick test to use. There's some other implications, but we're not going to go over those just yet. The idea, and this is going to be a really quick, loose argument, but the idea is we have something that, I shouldn't draw that, we have some term that's positive, and then some term that's smaller, the absolute value of it is smaller, but it's negative, right? So this is smaller than that, or the absolute value of that is smaller than that. So some of this will be canceled out. And then we have another positive term that's definitely smaller than this, so, and it's positive. And then we have a negative one that's smaller than that part, so some of it will cancel out. So we're only left with like little bits of positive things, and eventually we'll get down to nothing. It'll cancel out to nothing because this is going to 0, and half of them are canceling out with each other. So, I mean, that's the loose argument about it. Yeah, they're eventually going to just stop adding up stuff because eventually you're getting so small that you're canceling each other out eventually. But that's a very, very loose argument. We're not going to go into any more detail with that. But there you go. That's the alternating series test. Next comes the examples.